Imagine a near-perfect vacuum. Inside this vacuum, place two parallel uncharged metal plates, 100 nanometers apart. For no obvious reason, these plates began moving toward each other. This phenomenon is known as the Casimir effect, and it can be explained simply in 5 parts. Heisenberg's uncertainty principle states that we cannot know the exact position and momentum of a particle simultaneously. This can be derived to we cannot know the exact duration and energy of a particle simultaneously. Due to the inverse relationship between the energy and duration of a particle, particles with zero duration are likely to have a high energy which forces them into existence. These particles are called virtual particles and come in the form of matter and antimatter. All particles can be expressed as waves. This means that they possess both wave properties such as amplitude and wavelength, and particle properties such as mass and charge. There are an infinite amount of waves that can turn up. However, in an enclosed space, the waves must be a form of standing wave, and only harmonics or positive whole number multiples of half the wavelength of that standing wave can exist. You might say, how are some infinities bigger than others? Well, imagine this. There's a room with an infinite amount of chairs representing all the naturals between 0 and infinity. Let's say that all these chairs are occupied. What happens if another group of an infinite amount of people need to be seated in these chairs? Let's say that all these people that need to be seated have a decimal between 0 and infinity as their names, and that there are no repeating names. We could have all the people that are already seated move down to the closest even-numbered seat that's not occupied, and then the people that are waiting for a chair could sit in the empty chairs. However, since we can always end up creating a new decimal, every time we try and seat all the waiting people, we will always find someone with a name that is not yet seated. Since we can never end up seating all the waiting people, we can conclude that an infinity of decimals is larger than an infinity of naturals. Now let's put it all together. Virtual particles have masses and velocities. When they collide with the metal plates, they will exchange momentum and exert a force. Between the metal plates, there can only be waves with positive whole number multiples of half their wavelength. However, on the outside of the plates, any wave can appear. Since we know that an infinity of decimals is larger than an infinity of naturals, we can conclude that there are more virtual particles on the outsides of the metal plates than there are in between the plates. This results in a greater collision chance on the outside of the plates than there is in between the plates, and thus a greater net force pushing the metal plates together than there is pushing them apart. Consequently, the plates move towards each other. The Casimir effect has paved the way for many new findings, most notably Hawking radiation. Who knows what the future might hold for the Casimir effect?